My name is Graham Van Brunt. I am the lead instructor and founder for PSPT, which stands for Power System Protection Training. I've spent my full career in the power industry, and as such, I have a good working knowledge of what is important in the way of basic electricity, and that is why I developed this course. This course is entitled Basic Electrical Theory. It deals mainly with DC circuits, and there's going to be a follow-up course dealing equally with AC circuits. But the fundamental philosophies and theorems and laws of electricity will be developed using the DC circuits that you will find in this course. The course starts out with a fundamental understanding of what the nature of electricity is, right from the atomic level. It then moves on to a discussion of conductors and insulators and what makes up a conductor and insulator. It very quickly moves on to simple circuits and what happens with electricity in simple circuits. It talks about the flow of electrons making up electricity, and it also leads to the adaptation of what current flow is. From here, we move on to probably the most fundamental equation and law in electrical circuits today, Ohm's law in its various forms. We also move on to a discussion of power by first defining what mechanical power is, because that seems to be something that is easier to understand. And then we move on very quickly to what is electrical power and what are the formulas for electrical power using voltage, current, and resistance. Resistors are then introduced, and a brief description of the various forms that are out there and how they work and what their electrical symbols are. We then have the wherewithal to discuss what is meant by a series connection of these resistors and what is a parallel connection. This leads us to a couple of fundamental laws that are used for the analysis of circuit equations. That is Kirchhoff's voltage law and Kirchhoff's current law. With these formulas and laws, we then move on to mesh equations, and we learn how to reduce the complexity of a mesh circuit to basically one power supply and one resistor. The next topic that we move on to is circuit theorems. And before moving into the theorems, we define very clearly what the two basic DC sources of power are, and that is the voltage source and the current source, and what they mean to circuit theorems. The first theorem that we study is called Thevenin's theorem. It's a very simple theorem, and it's used not just in DC electrical circuits. They're even used in three-phase power and doing short circuit analysis. But Thevenin's theorem is developed and studied at this point in the course. There's also an equivalent Norton's theorem, which is also discussed at this point. This then gives us the wherewithal to be able to look at source transformation. That is, when we have a voltage source, how to convert it to a current source, and when we have a current source, how to convert it to a voltage source. Next, we move on to electrical fields and capacitance. electric fields are then defined, and then a look at how capacitors work in a DC circuit when they're switched on and switched off. Capacitor connections take up the next step, and that involves how you calculate the result of capacitors that are placed in series and when you place capacitors in parallel. After our discussion and analysis of capacitors, we move on to magnetism. In the study of magnetism, we define such things as magnetic flux lines, flux density, and what the SI units are to describe these entities in magnetism. Along with magnetism is the study of magnetic material, such as iron, steel, cast iron, etc. So that leads us to a discussion and a definition of what permeability is and how it describes these magnetic materials. Next, these magnetic materials are studied as they are affected by an electrical circuit or an electric coil that is wrapped around this core material. In the study of this magnetism, electrical magnetic induction is described, and a very important equation developed by Faraday is looked at and how it reacts in electrical circuits. This leads us to the development of something called inductance and a look at inductors. In this part of the course, inductance as a component of electrical circuits is developed, and how it reacts in an electric circuit, in a DC electric circuit, as power is switched on and off to an electrical circuit that contains these inductors. We then go on to describe how or what happens with inductors as they are placed in series and in parallel. As a final note, there is a discussion on practical considerations in regard to inductors and how they react in a circuit and how they interfere or possibly could interfere with other components, say on a circuit board. And that ends the course. As I said, there's a follow-up course to this one that discusses the same theorems and equations, but in terms of alternating current.